Hello everyone, in this video we're gonna present you the process of the setting up the simulation for the production of the aspirin in the Unisim design. As you can see, we already created our new project and the window of the components list view has opened up. Where we are searching for our four main components in the search bar. We are typing the names. It's gonna be the aspirin, also known as acetyl salicylic acid, the acetic acid, the acetic anhydride, and the salicylic acid. We are adding all the pure forms. That's the library of the Unisim design has all four of them, and just renaming the list of our components. After that, we are adding our fluids package bases, and for this case we are using the parameter of the Unisim thermal, and for the liquid phase we are searching for the non-random to liquids model, which are well suited for handling the non-ideal behavior of the liquids mixtures, which is exactly our case. And for the vapor, it's going to be the ideal gas model, since we don't expect any interactions of the vapor phases. After that, we are creating our new reaction, the kinetic reaction, filling up in the new window all the required informations about the components that's going to be used, their stoichiometric coefficients, the reaction rates of the forward and the reverse directions, and the minus ones for the coefficients that's used is marking that it's going to be our reagents, and the plus signs is going to be our products that we're going to obtain, and the ones and the zeros in the reaction rates, just showing that our reaction is straightforward and directed towards the obtaining our product. After that, we are putting all the parameters of the bases. It is a minimum and maximum temperature in which our reaction is going to be carried out, and the units of the bases and the rate. After that, we are putting the associations between the fluid package and the reaction set, which already has our reaction that we already created. And finally, we are now able to enter the simulation environment.
Hello everyone, so let's move on to the equipment part. The first thing that we may need here is the reactor where the esterification process will take place. I will add continuous stirred tank reactor because it is ideal for liquid phase reactions that need continuous mixing. Here I am also connecting three inlet streams to the reactor, one for salicylic acid, one for acetic anhydride, and the third one for any solvent that we may need. These are the main feeds into the reactor. Directly below the reactor I am placing a tank to hold the reaction mixture. This will help us to control and ensure the mixture moves smoothly to the next stage of the process. Right after the reactor, I will add a separator to act as the crystallizer. Crystallization will take place when we cool the mixture down to around 10 Celsius degrees. I will use a separator block here because it is the closest option in a Unisim to simulate a crystallizer. We need the temperature to drop in this stage so the aspirin can crystallize out of the solution, while the liquid phase, which is mostly the acetic acid, remains behind it.
Now let's add the centrifuge. I'll use the separator block again to simulate the centrifuge, which will separate the aspirin crystals from the liquid phase. This is a critical step as it ensures that we can recover the aspirin in its pure solid form, while the liquid, mostly acetic acid, can be filtered or discarded and recycled. After the centrifuge, I'll place a heater block. This will act as our dryer, set to about 60 and 80 degrees. The dryer is essential for removing any remaining moisture from the aspirin crystals, ensuring we can end up with dry, pure product. Let's not forget about temperature control. To cool the reaction mixture after it leaves the reactor, I'm placing a cooling block between reactor and the crystallizer. This will bring the temperature down to 10 degrees Celsius, a good range for aspirin crystallization.
Hello everyone. So at this point we can start working on the streams. First you can see I will define the feed streams for salicylic acid and acetic anhydride. Let's say we aiming to produce 1 ton of aspirin. Based on the reaction stoichiometry, we will need about 1,380 kilograms of salicylic acid and 700 kilograms of acetic anhydride per hour. I will enter these values into the stream properties window for each stream. Next, I'll connect the outlet stream from the reactor to the crystallizer and form the crystallizer to the centrifuge. The solid phase from the centrifuge will go to the dryer, while the liquid phase will either be recycled or sent to the waste treatment. So here I'll do some rearranging. You can see I'm just adjusting the pipeline layout so it's more visually clear. You can rotate and move the pipelines as needed to avoid cluttering the screen. It's important to keep things organized, especially when you're working with a complex flow sheet like this.
So now let's review the mass balance. I'll quickly check that the flow rates and compositions are consistent across all the streams. The incoming flow rates actually should match what we expected for the reaction, and the final output should give us about 1 ton of aspirin per hour, as we already said. And so I also want to verify that the pressures are set correctly, actually, because everything should be running at atmospheric pressure. And before we finish, I'll go back to the reactor block and double check all the reaction settings. I want to make sure that the correct reaction set is linked and that reaction rates are reasonable. For this process, the reaction should proceed at moderate rate, and we have already accounted for the heat released during the esterification. And so there we have it. The entire aspirin production process is now set up in Unisim design, and we've got the reactor, crystallizer, centrifuge and dryer all connected and ready to run. With the mass and energy balance checked, the system is ready to simulate, and in the next step I'll hit run to ensure everything is functioning as expected. But for now, this is the complete flowsheet setup. Thanks so much for watching, and we hope that this walkthrough, this tutorial helps you in your own process simulation work. And so if you have any questions, feel free to leave them in the comments.
So hello everyone, directly below the reactor I'm placing a tank to hold the reaction mixture. So this will help us to control the flow and ensure the mixture moves smoothly to the next stage of the process. So right after reactor, we'll add a separator to act as a crystallizer. Crystallization will take place when we cool the mixture down to around 10 degree of Celsius. So I'll use a separator block here, since it's the closest option in Unisim to simulate a crystallizer. We need the temperature to drop in this stage so the aspirin can crystallize out of the solution, while the liquid phase mostly acetic acid remains behind. So after that, I will add a centrifuge. I'll use also a separator block to simulate the centrifuge, which will separate the solid aspirin crystals from the liquid phase. This is a critical step, so as it ensures that we can recover the aspirin in its pure solid form, while the liquids, mostly acetic acid, can be either discarded or recycled. After the centrifuge, I'll place a heater block. This will act as our dryer. I will set it about 80 degrees of Celsius. The dryer is essential for removing any remaining moisture from the aspirin crystals, ensuring that we end up with a dry, pure product. Also, let's not forget about temperature control. To cool the reaction mixture after it leaves the reactor, I am placing a cooling block between the reactor and crystallizer. This will bring the temperature down to around 10 degrees of Celsius, a good range in our situation for aspirin crystallization. At this point, we can start working on streams. First, I'll define the feed streams for salicylic acid and acetic anhydride. Let's say we're aiming to produce 1 ton of aspirin. Based on the reaction stoichiometry, we'll need about 1,380 kilograms of salicylic acid and 700 kilograms of acetic anhydride per hour. I will enter these values into the stream properties window for each stream.
Hello again. So, as you can see on the screen, now we're changing some parameters for the acetylator. As we told before, it has 3 inlets. The first one is salicylic acid, the second one is acetic anhydride, and the third one is the diluent. So, after that, we are changing the conditions and the parameters of each of the inlet, and the first one is the salicylic acid. Here you can see some parameters as pressure, molar flow, temperature, mass flow, and so on. So the mass flow here is equal to the 1360 kg per hour in case of salicylic acid. So then we need also choose the parameters for acetic anhydride. The mass flow here is equal to 700 kg per hour, and also we need to change temperature and pressure. So the pressure here is equal to 100 kilopascals. And now we are returned to the conditions of the salicylic acid. The pressure here are the same, 100 kilopascals, and the temperature is equal to the 20 Celsius degrees. The same temperature we can observe in case of the acetic anhydride. So now we are rechecking the connections and the parameters of the acetylator. So I guess everything is right here. And now we are moving to the dryer part. So when we're talking about the parameters of a dryer, we are setting up that mass flow rate for both wet aspirin and aspirin product should be 1000 kilogram per hour. And then we also noted that drying process occurs at a temperature range for about 60-80 Celsius degrees, and that is why we also need to correct these temperature ranges. So at the end of the video you can see the final version of our scheme, and that's it. Thank you for the attention.